Welcome to the Meetup. We were supposed to do a real Meetup in person, but thanks to COVID-19, we're doing it online. And thank you so much for joining. It has been a tremendous journey with all of you. And today, I'm super excited to introduce our guest. We have Dr. Florian Baumann from Dell Technologies. He is the CTO focused with AI and automotive from Dell Technologies. Florian did his PhD from University of Hannover in machine learning with optic sensors. And I'm going to welcome Florian. And Florian, why don't you tell our audience a little bit about yourself, your passion, and introduce yourself and talk. What are you going to tell us?
Thank you very much. So it's a pleasure to talk in front of this audience. My name is Florian, and I'm working as a CTO focused on automotive and AI at Dell Technologies. And I am based in south of Germany. I'm working from home and focused on our global automotive strategy. And I'm responsible to take care of our customers that are focused on ADAS and AD development. Some background information: I was doing my PhD at the University of Hanover in north of Germany, and I was focused on optical sensor-based scene understanding using machine learning algorithms such as boosting algorithms, random forest, support vector machines, and I was focused on detecting a lot of objects out of still images or out of images. So for example, pedestrians, traffic lights, traffic signs, so everything that I got in front of the camera. After my PhD, I was moving to south of Germany, and I was working in Lindau for 3.5 years. And as you know, Lindau is somehow the Silicon Valley of driver assistance development, because a lot of prominent companies are located in Lindau. For example, Continental, ZF, Friedrichshafen, Denso is also located there. My old company is also located there. It got bought by Panasonic Automotive, and a lot of more suppliers are located in Lindau. So today we will talk about typical development processes of ADAS, advanced driver assistance systems, and self-driving cars. I would say for 80% of the participants and from our audience, I guess you are not aware of Dell Technologies in the automotive industry, but we are pretty prominent in the automotive industry. Dell Technologies is a huge company with around about 145,000 employees distributed across the globe. So almost in every city we have an office and a lot of R&D centers, and we are offering technology to the automotive industry. So for example, data management systems, storage systems, compute servers, and we have a storage system that is scalable and that can deliver a high performance for the development of self-driving cars and ADAS functionalities. And it's also very, very easy to manage. We have, as already mentioned, a global team of industry experts coming out of the automotive industry, such as system engineers, global architects, and a lot of more roles that are supporting our automotive customers in the development process of self-driving cars and ADAS functionalities. So we have a market share of around about 85% in the automotive industry. So we are serving around about 40 different ADAS and AD customers, and this is a big number, to be honest. And we are supporting our customers in enabling the connected and autonomous future. So we've estimated that, for example, mobility as a service platforms will generate around about 30% of the traditional automotive industry profit. And this is a huge number. And also, if we are focusing on predictive maintenance, predictive analytics, smart factories and operations inside of these huge productions, this area or this vertical could add another $160 billion of dollars in productivity gain. And if we take a look into the future, so during the next 10 years, we are estimating that 100% of the new cars will be connected. So connected to a cloud or connected to a data center coming from the typical automotive manufacturers like Daimler, BMW, and Volkswagen. And this is a trend that is 25% up from today. What I think, from my perspective, that is very impressive is that 50% of the vehicle value will be generated by electronics and software inside of the vehicle. If we think about a typical iPhone and Apple, for example, Apple is a platform provider. So Apple is providing the iPhone to you, and they are enabling a lot of third-party companies to generate business. And the business model for Apple, they earn 30% or 20% for each money that you are spending in the App Store. From my perspective, this will also happen in the automotive industry if we have self-driving cars on the road in 2030 or maybe 2040. So 50% of the vehicle value will be generated from applications and electronics inside of the vehicle. So you can customize your driver experience inside of the vehicle. I've identified 4 key automotive trends. One of the trends is connected vehicles. So how to connect the vehicle to the infrastructure, how to connect the vehicle to the smart city, how to connect vehicles to each other, how to standardize these connections, and what is the role of real-time streaming of data. So for example, it is possible to stream data in real time and to apply analytics or AI jobs in real time to the data that is generated by these vehicles. So let's assume a vehicle is driving on an icy road, and the road conditions must be communicated to the driver that on the back of your vehicle. So how to achieve this, to communicate this in real time to vehicles and also to the infrastructure. So the second trend is autonomous driving. Definitely, a lot of companies are collecting a lot of data from the street to train the algorithms. So data under different illumination conditions and weather conditions, different road conditions, must be collected to train the algorithms. And companies are thinking about how to manage the data. We are collecting petabytes of data per week. How to manage the data and how to also make this data available to developers everywhere in the world. And also very important is in-vehicle storage and in-vehicle compute. So how to already start preparing the data inside of the vehicle before sending it to the cloud or to the data lake. And also very important is data monetization. So how to identify new business models. What I'm also seeing in the market are partnerships between companies focused on technology and traditional automotive manufacturers, OEMs, and suppliers. So these companies are working on strategic partnerships to share knowledge, expertise, and the development to be the first on the market. From my perspective, the most asked solutions right now are focused on ADAS and the development of self-driving cars. So how to develop a scalable platform that enables companies to train and test on large scale. So if I'm talking about large scale, I'm talking about up to 100,000 of CPUs and up to 5,000 of GPUs, more than 200 petabytes of data. So how to develop an infrastructure that is able to train these neural networks on large scale. This is, from my perspective, at the moment, the most asked solution. And also very important is mobility as a service. So how to prepare for the change in the mobility that will come up during the next couple of years. And I guess everybody of you is quite familiar with these e-scooters that you can rent in bigger cities. Car sharing models like Moja, the startup from Volkswagen. So these cars are operating on virtual routes, and you can take your mobile phone and request a Moja, the taxi, to pick you up on a virtual station. And I guess everybody is aware of Lyft and Uber and all these companies focused on mobility as a service. Also very important is vehicle cybersecurity. So, for example, how to avoid car hijacking, and also how to make all these platforms and in-car storage and compute systems secure. You've seen the example of of a university out of US that tried not to hijack the car, but tried to change the speed of the car by simply changing some small characteristics in a stop sign. So suddenly the car didn't stop, it started to accelerate. Or another example is that some researchers out of US, they've manipulated a 60 kilometers per hour sign in that way that the car recognized the 60 kilometers as an 80 kilometer sign and it accelerated. This is very important. And also smart manufacturing, IoT sensors, how to collect the data from IoT sensors and IoT gateways, how to focus on predictive maintenance, and in general, how to extract data, value out of data, and how to extract characteristics out of the data. So a lot of more topics are also asked, such as over-the-air updates, in-car infotainment, telematics, navigation, and vehicle-to-anything connectivity, and also smart city integration. This is coming right now. How to integrate sensors into the smart city. Let's take a look to the typical development process of self-driving cars. And the process is quite complex. So first of all, we have the car on the street that is collecting data under different illumination conditions, weather conditions, road conditions, everything that comes in front of the camera. We are trying to select data that is worth to train the algorithms. And a lot of data is collected on the streets. And after the car is coming back to the development center or to the satellite or to the ingest station. So typically we have different ingest stations available. For example, one in Munich, or maybe one in north of Germany, another one in Italy and France. Everywhere are ingest stations to move the data into the data lake, into the on-prem data lake. And we are talking about 100 terabytes of data that is generated per day, but only during the development of these algorithms, because we do not have self-driving cars yet on the streets. They are still under development. As you can see, a lot of processes are running at the ingest stations, like labeling, so annotation stuff, pedestrians are labeled, traffic signs are labeled, road lane markings are labeled. And we are also focused on data cleaning, data preparation, and data compression to save costs and also to save data. Typically, we have a huge data center that is located, for example, in Frankfurt, in Amsterdam, in Detroit, in Shanghai, or somewhere in the world. Per continent, typically we have one data center, and all the developers are connected to this data center, and they can locate data and start the training process of algorithms. And data management comes in place and a lot of more stuff. What you can see right now is you can see two dotted lines, and the data center is typically connected to the cars on the field to push over-the-air updates on demand. So if the developers are increasing the performance of the algorithms, they can push an update onto the vehicle running on the street to collect the data to get a better performance of these algorithms. If we focus on emerging automotive workloads, and I've talked a bit about this already, we are focusing on data ingestion. Data ingestion means we have to copy the data coming from the vehicles into the data center. We are typically collecting 100 terabyte per day per vehicle. If we focus on annotation, so data enrichment and ground truth creation, we are seeing that thousands of labelers are working to access the data and to annotate the data. This is a cat, this is a dog, this is a pedestrian, this is a traffic light, this is a red car, etc. If we focus on AI training and evaluation, typically you see 50,000 CPUs and 5,000 GPUs in place. If we focus on synthetic scenario generation, that means we are trying to synthetically simulate the scenario. Why do we need this? So we need this because sometimes scenarios are too difficult to record in real life. For example, if you want to test an autonomous emergency braking system in a corner scenario, you of course don't want to hurt any people. And synthetic scenario generation is also needed to collect scenarios that are occurring not very often in the real world. So for example, your vehicle driving with 120 kilometers on a German highway into a tunnel under rainy conditions, whatever. So all these complicated and complex scenarios often cannot be recorded. So you're synthetically generating them using solutions out of the gaming industry. Companies, of course, after the complete development process is finished and successful, are testing the real physical hardware. It is called hardware in the loop testing. So you're taking your ECU and you're ingesting data into your physical device to test the reaction and the performance of your physical device. So around about 150 hill rigs are used per project, and another 6 terabyte of data are generated per hill rig. And the last emerging workload is focused on real-time streaming. So how can we enable a vehicle to communicate with a lot of different sensors located in a smart city, or also with sensors coming from different vehicles? From my perspective and Dell Technologies, I'm working in a business unit that is focused on storage. Why is storage so important? Especially focused on the ADAS and AD industry, storage is important because we have to deal with an extreme concurrency, an extreme scale. For example, on the right side of the page, you see all the different applications that are typically running in an automotive grade project focused on ADAS. And all these different applications are reading and writing data in parallel, random data. They are reading and writing this from the storage system. And on the left side of the slide, you see a lot of applications that will run in the vehicle after we have self-driving cars on the field. So for example, you are sitting highly relaxed inside of your self-driving car and you're watching some Netflix episodes, so entertainment stuff. And you are consuming data coming from the smart city. So the car manufacturer has to deal with fleet management and cost avoidance. And also companies will use the data coming from your vehicle for customer relations management. And all these different applications on the left side and automotive development processes on the right side are connected to the storage. And you need to have a data management in place, and you have to also connect the storage to the public cloud, for example, to consume some AI services coming from AWS, from Microsoft Azure, or from the Google Cloud Platform. So I guess this is the last slide for this presentation. And from my perspective, we have to deal with a lot of challenges right now. Very important is to speed up development life cycles. So for example, the complete life cycle from sending out vehicles to the field, over ingesting the data, managing the data until the start of production of these devices. You have to speed up this development process, and you have to also satisfy and make developers happy, because if the data is not arriving as soon as possible, if we are focused on large scale data sets, and I'm talking about hundreds of terabytes of data, you have to move this data from one continent to the other continent. You have to also make sure that these data moving and management processes are secure, and you are taking care of the GDPR. So you have to make sure that the privacy is assured and the security risk is limited, and you are compliant with regulations coming from different governments. And it's different if you are developing a self-driving car or if you are operating a self-driving car in Germany, in the region APJ, Asia Pacific and Greater China. This is different. And it's also different if you operate a car in the US. So you have to take care of a lot of different regulations and security policies. If we take a look to what's coming up after the next 15 to 20 years, you have to gain insights of zettabytes of data, and 1 zettabyte are 1,000 exabytes. You have to also adopt to new management models, and you have to also provide data to external agencies, for example. So what I'm often recommending to our customers is to focus on data ingest and data storage, and also data management. So to implement a data management system inside of the vehicle and also inside of your data center. And the last point is, as a giveaway from my side, focus on generating innovations and partnerships with technology companies. So thank you very much.
Thank you, Florian. It was really amazing. I do have a lot of questions. So as you know, that the second part of the meetup has been scheduled for me to make an interview with Florian. So we're going to move into that part. And thank you, Florian, for setting the premise of the interview. I do have a lot of questions from your talk. And to the participants, I would suggest that if you have a question, when we will be taking questions from you, you have two options. You can either write Q in the chat. If you write Q in the chat, then we'll give you video audio access. Then you can, talk to us. And if you would like to just ask the question in text format, then just write your question. So, Florian, again, thank you so much for the presentation. I have a lot of questions here. Yeah, let me start with the question of adversarial learning. You already mentioned a scenario where a 60 mile an hour sign has been somehow manipulated to show an 80 mile per hour sign. So these are adversarial scenarios, and we do want to address this. It's also a safety concern, a security concern, and that's what our meetup is about, autonomous vehicle safety and security. So can you tell us a little bit about that part of machine learning and its implication in automotive?
If we take a look to the example of traffic sign recognition, you're typically using some machine learning algorithms like a random forest classifier or a support vector machine. And these algorithms, of course, get trained by data coming from the field, so real data. And from my perspective, it is very difficult to avoid adversarial machine learning, or to avoid that this cannot be hacked somehow. This is not possible. But what you can do is you can try to focus on sensor fusion. So you can also incorporate data coming from different sources. Like we have our camera that is capturing the traffic sign, and we do also have our LiDAR scanner, so the laser scanner that could detect some objects coming from point clouds. And you could also take some data coming from mapping providers, so data coming from a real map that shows you with 100% of safety that this is a 60 speed sign. And then it gets very difficult to hack these systems. But from my perspective, you can hack every algorithm and perception system.
Fantastic. So having said that, you gave an example of connected vehicle as well. Your vehicle will not only be connected with the backend, it will be connected with the infrastructure, it will be communicating with other vehicles and traffic signs and so on. In that scenario, you also mentioned a car hijacking way. Yeah, this is something that we want to mandate, that autonomous vehicle should not hit a human. This should be programmed. The autonomous vehicle should not be allowed to hit a human. If there is a human in front of you and the autonomous vehicle detects that, you should stop. That should be a safety feature. And this safety feature kind of allows, the example you gave, the car hijackers to surround the vehicle so that the vehicle stops and then physically hijack the car. What do you think of such scenario? Are your company, or how is the industry taking such scenario in context?
From my perspective, it's not really possible to avoid this. And if we take a look to the situation, if we have it right now on the street, I mean, you can stop every car that you want by jumping onto the street or maybe blocks the road. And then you can also hijack the car by taking a gun in front of the driver and telling him, hey, go out of the car. And this is the same scenario if we have self-driving cars on the road. So I guess you can't really avoid it.
Okay. All right. So this is something that we can't avoid, however, something to think about. All right. We had the ISO 26262 standard for a long time. And now we have an extension or even an individual standard from ISO, which is safety of intent and functionality. You mentioned some of those testing that you have to test. You mentioned game engine. Now, traditionally, I agree with you that in our automotive industry, we've been using game engines for our simulation purposes. Now, the problem with the game engine is, as you have seen probably when you've played Counter-Strike or that sort of a computer game, sometimes you walk through a wall. So simulating the real physics is not the focus of game engines. It's more entertainment or the graphics or the effect they focus on. Now, do you see some challenges in testing when it comes to autonomous vehicle simulation and so on?
First of all, we have to differ between different test scenarios. So there are a lot of test and validation processes in the automotive industry. One of the most prominent ones is hardware in the loop testing. So you're ingesting the data into the physical hardware to test the reaction of these systems. And another test is called software in the loop testing. So you are ingesting data into the software module to test the reaction of the software component. And there are also a lot of more tests that are focused, for example, on model in the loop testing, vehicle in the loop testing, driver in the loop testing. So it's really amazing. But coming back to your initial question, and if we focus on self-driving cars, I do not really see standards right now in place to test different ADAS functionalities of self-driving cars. So a lot of certification authorities are starting to introduce standards, because especially if we focus on self-driving cars, there's only one safe. There is no differentiation between different types of being safe. The self-driving car must be safe. That's it. And a lot of companies or startups are focused on introducing standards to test and validate these systems. And what we also need is a so-called homologation of self-driving cars. So for example, in Germany, we have TÜV and DEKRA, and in China, we have CATAC. In US, we have NHTSA, and these certification authorities, I guess, from my perspective, they are working on standards on how to homologate self-driving cars, how to make them safe for everybody. And there won't be a difference between a self-driving Volkswagen or a self-driving Ford. All these cars must be safe.
I understand. Thanks for talking about the text methodologies. Obviously, in the V cycle, if we're doing requirement-based test, Mill-Sill Hill, vehicle on the loop, and all those will come. And you rightly mentioned that there is no standard. Standards are stepping into it to standardize the safety of autonomous vehicle. And SOTIF is one of the initiatives among many. By the way, SOTIF in its current status talks about level 1 and level 2 merely. So it doesn't even go to level 3, level 4, or even level 5. So there's a long way to go. So my question was more, if you simulate, because we need a lot of data. I mean, there are some companies talking about that we need 10 trillion miles of data in order to decide how is really safe in case of autonomous vehicle. Some companies are saying we need 7 trillion miles. So we need huge amount of data. And your company is working at the forefront of this data collection. With those data, what we can do is simulate, and based on those simulations, you're practically building the AI of the car. And once your AI is built with the data that you're collecting, we need to test them, verify them. Yeah, and 10 trillion miles or 7 trillion miles, whatever that is practically not feasible to do in real vehicle. We need to simulate. So do you see any problem based on that we are using game engine, not real simulation that, for example, defense industry use, to simulate or space industry use, because physics matters much more than the game industry in those industries. What do you think of that?
Yeah, fully agree with you. So I was working at my previous employee at a project that was focused on how to measure the difference between effects coming from synthetic scenario generation and real data. And from my perspective, nobody right now really knows what these effects are. And you got the point. So a physical sensor simulation is very difficult. And from my perspective, there are no companies that can really focus, for example, on good physical sensor simulation and also on high quality scenarios. This is very difficult. And also, if we are incorporating, for example, vehicle dynamics, it is very, very difficult to simulate all the different sensors like cameras, lidars and radars, vehicle dynamics, CAN information. It is not yet possible, but I do see a lot of companies, startups and global players who are focused on realizing this high quality simulation. And I guess it's just a question of the time and a question of how many compute. Just to give you a number, I was talking to a company a couple of months ago, and they told me that they are paying $1 per frame that is generated from the engine. And a typical camera has 60 frames per second, so $60 per second. And we have 13 cameras inside of your vehicle. So you can calculate how much money these companies are spending to simulate the data in the public cloud. It is not yet solved, and I know that the European Union and the German government funded some public projects, so corporations between universities and companies, to measure the difference between simulations and real data.
So Florian, just for me to understand very clearly, $1 per frame of your camera. In which case are these companies spending their money for?
To simulate the scene, to simulate the single frame in the public cloud, right? It becomes cheaper if you're deploying this on-prem, but you need a lot of computing power to create high quality scenes and also to create a very good physical based sensor simulation.
You know, you talked in your presentation a lot about collecting data. So it looks like Dell Technologies is collecting a gigantic amount of data. And from this data, you want to monetize, you want to understand certain road conditions and so on. Where do you collect this data from? Do you collect this data from the OEMs? Do you collect this data from the drivers? How do you collect it? What is the source of your data?
Dell is not collecting data. We are enabling companies to collect the data themselves. But of course, these companies are not collecting the data on their own. So they are subcontracting this to suppliers. This is very, very typical in the automotive industry. So there are companies responsible to collect the data in different countries. Each of these vehicles is generating up to 100 terabytes of data. Of course, it depends on what kind of functionality you are developing. Yeah, this data must be collected in different countries, regions, under different conditions to train the algorithms.
So if I understood you right, the OEMs or your clients are subcontracting companies to drive around and collect data and send it in their backend. And Dell Technologies is the technology provider or enabler for such scenarios. Is that true?
Yes, we are providing the backend, or maybe in-car compute and in-car storage. So the systems inside of the vehicle that is collecting the data.
All right. I have another question that when you're collecting data, you're using it for deep learning and so on. What kind of implication do you think deep learning is going to have in autonomous vehicle?
So from my perspective, deep learning will find its way into the self-driving car industry. And this is what you can see on daily basis for all of these companies. But this won't be the only solution that enables cars to drive autonomously. We will also need traditional algorithms such as machine learning techniques or computer vision techniques such as 3D reconstruction methods and a lot of stuff that came up 20, 30 years ago. So, of course, deep learning is one of the most important solutions.
In machine learning field, deep learning is really the game changer. So I'm really curious to see how it affects the autonomous driving sphere. Thanks for talking about that. There is another last question I have is about GDPR, you already mentioned. The definition of personal data in GDPR is really generic. Anything that can relate to a person is your personal data. GDPR also talks about personally identifiable data, which is a little bit narrowed down, meaning that you can triangulate a person. You can identify that person from their data. So when it comes to personal data, pretty much everything in your vehicle can be related to a person, even your gasoline level or the tire marks, and everything can be related to a person because right now a person is driving it. Do you see any hurdle for the automotive industry when they're collecting such data? Will there be any compliance issues? How do you see that?
You have to differ between collecting data for the development phase of algorithms to develop self-driving cars, and you have to differ between the production of these vehicles. So, for example, if we have self-driving cars on the road, and if you focus on the development of self-driving cars, you have to make sure that, for example, are not sharing the data with third-party companies. So you are not allowed to move over the data to a supplier, for example, as long as you can identify people. So, for example, if there are some faces inside of your scenarios, and this is obviously always the case. You can't really make sure that you are not recording faces, and you need these faces to train the algorithms. And what is also not allowed, for example, is to identify number plates. So the best example is Google Street View. If you take a look to Google Street View, you can see that faces are blurred and also number plates are blurred. So you can't really recognize them. And if you make this data public, or if you share this data with third-party companies, you have to make sure that this data is anonymized. If we focus on self-driving cars on the field, so after the production, of course, you have to make sure that the GDPR regulations are followed. And I mean, this is nothing else than using your iPhone somehow. If you drive in your self-driving car, you will get a disclaimer that everything will be shared with the manufacturer of this car. I guess this will happen somehow.
Fascinating. With that question, I think this is the perfect segue to move to the next phase of the meetup, which is taking some questions from our audience. We already have some questions that I can see. If you want to be a part of this meetup, where we will put your video and audio data online, you're more than welcome to do so. However, this would mean that you're giving your consent from a GDPR sense. If you don't wish to give your video and audio data, please write your question. We'll take your question in text format. So why don't you give Ramkumar the video audio right so that we can take the question.
Hey, hi, Hasan. Can you hear me?
Yes, I can hear you. Welcome to the meetup. Can you please talk a little bit about yourself, where you're located, and ask the question?
Hey, thank you guys. Thanks a lot for joining. And this is Ramkumar here. I do have around 13 years of experience working in automotive industry. I'm currently located in India, and I'm part of the Automotive Spice Consulting, where I have done Automotive Spice Consulting for OEMs and Tier 1s. So that's a brief about me. So the question that I have right now was, Florian, you talked about the standards, that we don't have any standards right now specific to ADAS right now, right? So my thought process is, can we use the combination of ISO 26262 on the cybersecurity standard that we have right now to ensure safety and security, assuming that we don't have any standards in place? Can we use those standards? That's my question.
Yes, so of course they can be used, but these consortiums behind ISO 26262 and SOTIF, they have to extend these standards to also cover self-driving cars. Because at the moment, Automotive Spice and all this stuff, I mean, it's focused on V-model process development, but it's not really focused on cybersecurity. So how to avoid that a self-driving car gets hijacked, or that the camera or LiDAR sensor or radar sensor gets hacked. And this is an area that must be investigated, in which we have to extend the existing standards.
All right. Thanks for that, Florian. Thanks for the clarification. Yep.
I want to add one more thing to that. I mean, you've mentioned ISO 26262 and cybersecurity standard. I assume that you're referring to the ISO 21434 standard. Even the ISO 21434 does not even talk about autonomous vehicle. ISO 26262 does not talk about autonomous vehicle. There is a long way to go. Even SOTIF just talks about level 1. And probably, I'm not 100% sure, probably also level 2, and most probably only level 1. So we have a long way to go.
I agree, Hasan. I agree. Yep, you're right.
All right, Ramkumar, thank you so much for joining. Do you have any other question, or should we take the next one?
No, we can take the next one.
All right. Yes, Suraj, why don't you talk a little bit about yourself, what you do, your background, and ask your question.
I am SOTIF expert and ISO expert working within Continental. And I'm looking after L3 and L2 plus driving projects, mainly supporting development of safety concepts for such kind of functions. Before I jump into question, once again, whatever accidents that we have so far seen on the field, consider Tesla accident or GM Cruise or even Uber, what I understood was all the accidents were because of combinational hazards that we have seen. When I say combination of hazards, my question is, are you considering any method to ensure that all possible combination of hazards you have covered, and so you have enough number of scenarios against that? If I validate my function, I will be able to say that now it will be foreseeably safe to launch my validated function onto the streets.
The problem that I'm seeing is that you cannot connect all the different scenarios and circumstances that are needed to make the self-driving car really safe. If we take a look to the human behavior, we are learning from the history and from being a child, and we are reacting very often intuitively. And this is somehow what you cannot really teach to a deep learning or machine learning algorithm on how to react in that situation. This is not really possible, and you can't connect all the different scenes and scenarios and use cases, corner cases that we have out there in the world. It's, from my perspective, not possible.
I totally agree with Florian. I think the way we have to define a roadmap towards autonomous vehicle is the first generation of autonomous vehicles should be somehow geofenced. I really like the question because, like Florian said, it's just not possible to cover all the scenarios, and we'll never be able to achieve that. There's no question about it because it's just too vast. It's almost infinite. Now, what we can do is we can always go first geofenced. And once we start geofence, we'll be learning a lot. By geofence, I mean, what is the difference between a train and a geofenced autonomous lane? Do you see there isn't any difference other than technology? It's practically a train. And we do have a lot of experience in trains. So we can use that experience in order to learn how to go toward autonomous vehicle in a geofenced environment. And that should be the first generation before we even think about the level 4, the level 5 that we talk about. When people say level 4, level 5, what do they mean? If by level 4, level 5, you mean one car able to handle every scenario, then I totally disagree that I think we're far, far away from it. And I would quote the CEO of Waymo, John Krafcik, who's very honest about the standpoint of technology. And he said they'll not be able to make such vehicle that'll be driving autonomously in all weather condition, under all circumstances. That's just not possible.
Okay, thank you for all the replies.
Thank you, Suraj. All right, should we move to the next question? Harshvardhan, so we'll give it to you.
Hi, everyone.
Hello, why don't you talk a little bit about yourself, a short intro?
I'm the student. Right now, I'm studying Masters in Electromechanical Engineering in VUB University in Brussels. Previously, I had 6 years of experience in mechanical design engineering. Right now, my course is based on the 50% electrical, 50% mechanical. So I'm just curious about what are the exact demanding domains in the automotive sector, and how can I prepare myself for the new upcoming challenges?
The question is how to prepare yourself for the upcoming challenges around self-driving cars and artificial intelligence.
Yep.
I would recommend you to read a lot of public available material. For example, I guess one of the first steps is to join a webinar or a meetup like this one, to talk to experts and to educate yourself. And there are also a lot of resources available to train yourself around self-driving car development and ADAS development. Online courses, training courses are available. And there's a lot of public material available at GitHub. You can check out free ebooks and papers from GitHub or from ArchiveX. I guess it makes also sense to attend one of the leading scientific conferences. So what I can recommend you is, for example, the CVPR conference. This is Computer Vision Pattern Recognition, CVPR. This is one of the best conferences of the world, focused on machine learning, deep learning, computer vision, 3D reconstruction. And there's also another conference called ICCV, International Conference on Computer Vision. And another conference is, for example, ECCV, European Conference of Computer Vision. So you do not really need to attend these conferences in person. In most of the cases, you can download the papers and read through them, or read some summaries provided from some PhD students. So yeah, it's just learning, watching, listening to podcasts, webinars, webcasts.
Thank you, Florian. This is a very, very useful answer. And Harshvardhan, I really appreciate you joining. We really encourage students to join. Thank you so much for joining. Do you have any other question, or should we move on?
No, thank you. Thank you so much.
Thank you.
Thank you.
All right. Peter Spence, you've given the audio floor. Hi, Peter.
Hi, thanks for taking my message. I've been involved with the functional safety industry for about 12 years. Currently, I'm with Tulsa. And my basic question right now is relative to the security question that...
Peter, where are you located?
I'm in Los Angeles. Without further ado, I just want to move on to the question. It's kind of a two-part question on the security issue. I think it's a big concern for everybody. Certainly when we move into this aspect of autonomous drive testing, like everybody mentioned, there's no real standard right now. The SOTIF standard is a big gray area for everybody. But my question to Florian is, as the platform owner, how can you be totally sure that we've optimized our security mechanisms on the platform and we've achieved some confidence at both the product and platform level? And how can this then be migrated to the OEM so that they can actually go and understand their individual security concerns at the product level? So I'm not too sure if that makes sense to you, but first of all, I think that the platform is the starting point for everything, right? And that could be a safety element out of context problem. Then we move on to the individual products that are actually connected through the different domains. And I'm wondering whether or not Florian could actually give me some kind of indication on when the autonomous car's on the road collecting data, how does Dell give confidence to the OEM that individual security concerns are actually taken care of? So are you actually putting some kind of safety net in there to actually ensure that no hacking is actually taking place and that all the individual products which are actually on the vehicle are also secure? So I'm not too sure, again, Florian, if that makes sense to you, but...
Yes, I got your question, and this is in fact a very good question, and this is very often asked by our customers, but I can answer this quite quickly. So we are not developing in-car systems that enable cars to drive autonomously. So we are providing the back end, the data center behind the vehicle that collects the data and that enables our customers, the OEMs, to apply algorithms and analytics jobs. So we are not inside of the vehicle. But this is a very good question, to be honest. From my perspective, nobody has an answer right now. I mean, and my personal opinion is you can hack everything that you want. And all systems that we have inside of a vehicle got hacked until today. CAN messages decrypted, and take a look to the possibilities around tuning your engine through software hacks. Everything is possible and everything gets hacked. This is my personal opinion.
I agree with you. It's because I've been involved with the mobile phone industry as well in the past. I saw the problems associated with different platforms for different mobile carriers. And, obviously the responsibility there was probably at the platform level, of course. So lots of lab testing that needs to be certified before the actual platform is actually sent out for commercial release would be the optimum way to go with it. That's why I was kind of asking you whether or not, from a platform aspect, are we looking for compliance at a platform level, and then everything else on top of that would be the responsibility of the individual product owners. But you build your products on your, from a platform standpoint. So I would have thought that the platform is the most important thing to actually have compliance on it at the very beginning.
So you're talking about platform. I see in automotive there are 3 layers where security breaches can happen. First one is in vehicle, like Florian mentioned. CAN messages can be decrypted. There are vehicles in the street with no encryption in the CAN messages. They're there. So this is in vehicle. Now you have another layer. The second layer is vehicle to the infrastructure. So vehicle to the back end. How do you secure that? And the third level for me is what you're mentioning, the platform, the infrastructure. How do you secure the infrastructure? Now, This is what I tell my clients, that if a person have built a system, there is another person out there who will be able to break the system. So it's axiomatic. Now, how do you secure that? You definitely do the defensive mechanism. That's why you have your standards, your all defensive mechanisms to secure the connectivity within the vehicle and the infrastructure, the platform. This is the defensive mechanism. You have to do that, but that's not enough. You have to go in offense. What do I mean by that? You have to constantly deploy your red team to hack yourself before the bad guy hacks you. Because zero-day exploits will be coming all the time, and things will be changing all the time because you'll be shipping updates. And that's why a defensive mechanism along with an offensive mechanism is necessary. Does that make sense to you?
Yeah, sure. Without question, it's probably the best train of thought, I think. And then the other thing, of course, it's over-the-air updates. Who will manage that? Is it going to be the OEM or is it going to be the platform owner?
So I would say this is the OEM, definitely.
I agree with you up to a certain level, because there, when it comes to an automotive, there's certain code part that is owned by the OEM, and there's certain code part that is owned by the tier ones. The tier ones do not even provide those code to OEMs. And there's oftentimes very safety critical. So it will have to be a mix. Obviously, the OEMs should have the front end of doing it. However, OEMs do not have access to the entire code.
I agree with you, but I guess this will be changed during the next 3 to 4 years if we take to the ZFAS system, for example, from Volkswagen, a centralized ECU responsible for perception, action. And this, I guess this will be changed so that suppliers have to deliver source code.
I think that I would agree with there. To come back to Peter's question, between the platform and the OEMs is definitely OEM, yeah. Peter, do you have any other question? Anything else that you would like to discuss with?
Again, thank you very much.
Thank you, Peter. Michelle, who do we take next?
We are ready, just no questions.
No more questions, all right. Then thank you so much for being a part of us, Florian. We will take a short break. And as scheduled, I'm gonna entertain a Q&A. So you can ask me every kind of questions from autonomous vehicle safety, security. I'll try my best to answer your question. So how about we take kind of like a 5 minutes break, recess a little bit, and come back and see you soon. Hello again. I hope you're still there. Yeah, many of them are still there. Still have 41 people. Before we go to the Q&A, let me tell you a little bit about, we have just published a white paper on ISO 21444, bridging the gap of cybersecurity and automotive engineering. And whoever you're joining here today, you will receive a link to download the white paper. Please feel free to download the white paper. This is a very informative white paper, a very timely white paper, because ISO 21444 is coming out. This is going to impact how we work, how we do this. Yeah, if you have any question, we will give you the mic. Who wants to take the question? All right. Chitra. All right, well, why don't you give her the mic?
Hello, Hasan. Thank you for joining me for this WebEx session.
Can you talk a little bit about yourself, where you're from and your background?
I'm from India. I'm working at Continental as a FSM assessor. I observed that in most of the companies, function safety and cybersecurity courses are established independently and they do not interact each other. I think when a company is working for a system which has both the concepts of function safety and cybersecurity, there should be an interface established within the company to have the interface, how exactly the escalation or how the interaction should happen between these two aspects. So I just want to know your opinion on this.
Chitra, it's a very good question. I love this question. So it is, I 100% agree with you. There are companies where you have siloed environment of functional safety people and security people. Is it right or wrong? The answer is yes or no. Because there are certain aspects of security that has nothing to do with safety. For example, security can have 4 kinds of impact. It can have financial impact, it can have privacy impact, it can have operational impact, and it can have safety impact. So when it's financial impact, I mean, your credit card can be stolen, your data can be stolen, privacy impact, or operational impact. Operational and safety impact are correlated. So one can cripple your car and that can be also endangering your life. Now, in these two aspects, safety and operational, there is no way you can avoid working with the safety department. They have to work hand in hand. How many times have you heard our beloved safety colleagues saying that, look, I'm responsible for safety, I have nothing to do with security? And that's a statement that cannot be right anymore. You cannot accept that statement anymore because your security will have safety impacts and you will have to work hand in hand in both the department. And I totally agree with you that you have to develop an interface. Now, when you do your safety analysis, for example, HARA, you will come up with safety goals that can impact your security goals. And on the other hand, when you will do your TARA in your security analysis, that can come up with some security goals that will impact your safety goals. Now, these are the two things that I'm talking about, two aspects. There are more to that. For example, SOTIF is one. You can have SOTIF goals that will impact your security or safety goals. So these three right now, these three areas have to work hand in hand. The methodology that I propose to my clients is like three parallel V's which are interacting with each other or giving input to each other at each iterative stages. And I think right now that's the only way to move forward. Otherwise, if you have not only impacts, in some cases contradictory goals that you'll come up with, your TARA or your HARA will bite you when you're actually way below the V model in the verification phase. So it is better, it is cost effective, it is much more cost effective to work hand in hand at the top of the V model rather than to wait for all the way down and discovering that, hey, we have a problem here. Chitra, does that answer your question or do you have anything to add?
Perfect. Actually, this is the answer which I was in fact expecting.
You're located in India. Which company do you work for again?
I work at Continental.
You work at Continental. Fascinating. So stay healthy, stay safe, and thanks for joining.
Thank you. You too. Take care.
So COVID-19 makes us do things that we would otherwise not do. I'm really liking it. You know, people from all over the world. I mean, if this meetup would have been a personal meetup, we wouldn't have people from India, we wouldn't have people from Los Angeles and different part of the world. It's amazing. I'm really enjoying it. Okay, we have another question. Michelle, do you want to give him the Azad Ansari?
Hello, Hasan.
Hi, how are you doing?
I'm doing good.
So why don't you tell a little bit about yourself, where you're from, and ask your question.
Okay, I'm Azad Ansari, software function leader of telematics in Mareli, India. We have the global presence across the different continents. So my question is how the devices in the self-driving cars are secured with reference to the A2 process. Basically, I am from the telematics background. If we have the different devices, different issues interconnected with each other, we need to do the cyber secure some issue. I want to understand what are the various types of safety measures need to be considered.
Very good questions. So you are when you are saying autonomous vehicle, are you talking about level 4, level 3, level 2? Which level are you talking about? Because the first thing we have to, when we talk about autonomous vehicle, we have to get the definition right, that we're talking about the same thing. By autonomous vehicle, if you're meaning that a car that can do everything on its own, we're really, really far away from that. So can you please specify, what do you mean by autonomous vehicle? Is it the ADAS functionality only, or what do you exactly mean?
ADAS functionality will be there. Apart from that, it must have all the safety measures along with that. So I will be saying it will be in between level 3.
Let's look at how the vehicles are secured today. So there was a time when CAN was developed, the controller area network that we have for you talked about ECU to ECU communication. When we developed that, we did not have security in mind. Nobody thought about security at all. Now, we have millions of cars out there in the street with that concept. This is the example I give again and again. If you have studied computer science in late 90s, you remember this Windows network was so easy to hack into. You had your MSN Messenger that your friend was sending a message from node A to node B, and you could sniff into those messages in your network so easily. Anybody who had studied computer science in that time kind of, even if you haven't done it, you have kind of played with it or heard about it. There is actually another video in our YouTube channel. My colleagues from Matrickz have done it, where we show how easy it is today to sniff into a CAN message and manipulate it in today's vehicle architecture. So there are millions of cars out there with that architecture. Now, what's the next advancement? Obviously, there are advancements out there. We have HSM, secure hardware module technology, well advanced in the meantime, and it's affordable for automotive industry. And as you know, automotive industry is very, very price sensitive. So with that, AutoZar also offers an interface to implement those in your system. So it's getting better. So the vehicles that we're making today has some, encryption mechanism, some challenge response protocol built in. What will happen in the ADAS domain, autonomous, when you go to autonomous vehicle, the first step is ADAS, what the driver assistant functionality that is available to us today. Obviously, it's more secure than before, but there is a big unknown part. When it comes to autonomous vehicle, when it comes to beyond your vehicle, the environment, so ISO 26262 focuses on the vehicle safety. So what can go wrong in your car? SOTIF goes beyond the vehicle. When it is beyond the vehicle, there is a big unknown part. Unknown part meaning that you can't answer a lot of questions. You just don't know. If you know something, you can take measure. If you do not know something, there's no way you can take measure. So from safety and even security perspective, when it comes to anything that when you're taking the data from your environment, be it your radar, be it your camera, be it your lidar, when you're taking data from the environment, there is a big unknown, and that is really, really hard to make safe or even secured. Having said that, technology in automotive has made some advancement in terms of security. And there are 4 areas where I see there are great advancements. One I already mentioned is the HSM. The second one is we have a standard draft now, which is coming out, ISO 21434. The third area is firewall. You work with telematic unit. A lot of attacks come from the outside world. So if you have a firewall to secure your gateways, that's a big advancement. Again, these concepts are nothing new in traditional IT domain, but it had to be re-engineered for the automotive industry. And finally, AutoZar has been providing a lot of cryptographic or security mechanisms, especially adaptive AutoZar. So these are the areas where I've seen advancements, and these are the technologies, to answer your question, that you can take in your telematic control unit that you are building in your specific area. Wherever it's appropriate, you can apply these technologies. Does that sound good?
I appreciate.
Thank you, Azad. Really appreciate you joining and asking question. So Vikash, welcome. So why don't you tell us a little bit about yourself and ask your question?
Hi people, this is Vikas here. Presently I'm living in Germany. I'm here for my master studies. I've been working in India for around 2 years in some material handling industry. So I would like to know, what would your suggestion be to someone who is new to this industry, and what aspects of this industry one can include in his study curriculum or something of that sort.
Fascinating. Really, really appreciate it. I like it when students join. We always welcome students to join. The fact that you're joining this meetup, that already says that you're interested. When you're interested in something, that is already a big thing. Now, to answer your question, if you want to have a guideline in which direction you should go to, I will have to have some specifics about you, because I do not give a really cookie cutter generic career advice. Can you tell me a little more about yourself? What have you done and what are the things that you're passionate about? Where exactly are you studying now? And which stage of your studies are you in?
So I have completed my bachelor's in mechanical engineering. And I always had a focus towards automotive industry. And my bachelor's or the work experience that I had, because of the conditions, I was not able to take up something related to this field. But I decided that when I take up a master course or something of that sort, I'll try to shift and follow my interest. And this particular web meet got me interested. I want to pursue something which involves automation and something related to automobile and its automation.
All right. So you're doing your master's, if I understood you right. And where exactly are you doing your master's and what's your master's program?
So I'm yet to begin with the master's. I'm actually currently taking up a language course in Germany and about 6 to 8 months time. So in this while, I would like to plan my education. I can apply to universities at the same time and also check for courses which would have a specific module.
Gotcha. All right. Then let me go back to your bachelor's studies. In your bachelor's studies, what are the things that you liked most? Are you a programmer? Do you like programming? Or do you like mathematics? Do you like what was your passion? What was your strength?
I was more into problem solving, so I was better with planning and root cause analysis for a particular problem you face in the industry. So the project that I did in bachelor's was with a firm where they had difficulty in manufacturing.
Yeah, I understand. Vikash, it sounds like to me, and I would be totally honest, you are yet to discover your strength. So there are a lot of things you can do. The problem in 2020 is not lack of options. The problem is too many options. There are way too many things that you can do today. And that is really the problem. I try to deal with these things is reverse engineer myself, knowing yourself, knowing your strength. And when you say you're good at problem solving, you have to go really narrow. What kind of problem are you talking about? Are you talking about you're an engineer, you're a mechanical engineer? Are you talking about mathematical, mechanical engineering problem? Are you talking about process-like problem? Or are you talking about generic problem? You really have to reverse engineer yourself before you decide to go and enroll for a master's program. But on the other hand, what I'm going to tell you is you're really young. Don't rush. Don't have to have it figured out within a year or two. I mean, the master's study could be a place where you're still pondering and where you want to go. So take time, find out your strength. Is problem solving is your strength? Then go in that direction. Find out what problem do you want to solve. And now if you ask me, in automotive industry, we look for talents all the time. The job market is looking for youngsters like you. There is no question about it. However, what I suggest everyone that before deciding, find out your own strength and only bet on that. A lot of people will put a lot of effort to find out, oh, this is where I'm weak, maybe I should work on that to balance it out. I don't do that. So I really appreciate you asking this question. I would recommend you just go and ponder and ask yourself, narrow it down as much as possible, keep doing what you're doing. And in 6 months, if you have to come back to this show again, I'll be happy to answer your question when you have more specific and concrete info about your own strength. Does that help?
Yes, that's very helpful.
Thank you, Vikash. Really appreciate it. Okay, we have another question. Harvardon.
I have the same question about whatever the Vikash has told about it. Before that, I would like to tell you something about me. Actually, I'm doing right now Masters in Electromechanical Engineering, which is quite related to 50% electrical electronics and 50% mechanical. Previous that, I was working with Bharat Forge as a manufacturing engineering, and then after I shifted to as a design engineering. So almost I have the 6 years of experience in that field. Now my master study is totally different than those experience, which is quietly related with the electrical vehicles, hybrid vehicles. So I would like to know more about which are the focus areas in my master study. I could do more focus on that, and which are the things in my study which will help for my career in automotive domain. So could you just elaborate on that, and could you just share your experience on that?
Absolutely. Absolutely. Good question. Anybody who will tell you that in the next 5 years, ADAS or this field of autonomous driving is going to be really good, they're right. I don't disagree with them. The problem there is we're living in a time where the only thing that will be constant is changes. How the future is going to look like, we don't know. But one thing we know about the future, that it's going to be different. Now, if you are thinking that the skills that you're learning today, and these skills will still be applicable in, 10 years or even 5 or even 2, most of the cases you'll be making mistakes. I suggest everyone that your ability to adapt to changes is the one that is necessary. So in which direction, Harshvardhan, you will choose your master's thesis or master's focus, you'll have to reverse engineer it for yourself. You should never listen to the advice of a person like me, because you and me, we're different. I will be talking from my perspective. It has to be right for you. And the one thing that I would suggest is your ability to adopt. The fact that after 6 years of career, you went for a different master's thesis already tells a great deal about you. You are able to deal with changes. And that's why I think you will have no problem wherever the technology goes and wherever you want to take yourself. I think you're completely in the right direction, and trust your instinct. You have done the right thing so far, and I'm sure you're going to do the right thing in the future.
Thank you so much. I just wanted to do my career in electrical vehicle and hybrid vehicles. So that is my subject.
Love it. If that's what excites you, it's going to be your thing.
Thank you so much.
Elgarbe, if I'm pronouncing your name right or not, please correct me. You should have the mic.
Hello.
Yes.
Yeah, El Garbavi.
El Garbavi. Fascinating. Welcome.
Yeah, thank you.
Yes, your question, please. Yeah, you tell me a little bit about yourself, your background, and your question.
I am developer engineer at Mercedes-Benz. I have a question regarding the interaction between SOTIF, HARA, and TARA. Is there a similar standard to define test activities with the security topics? Mm-hmm. You know that the SOTIF, the safety of the intended functionality standard, define the interaction between verification, validation, and accreditation activities, and this should be done for functional safety and the intended functionality. You know that is also by SOTIF standard, there is also definition of required, implemented, and the intended behaviors of the automated driving function or ADAS functions. So the point that you mentioned, that the safety engineer should ensure that this interaction between safety topics should be also covered with security topics. And from my point of view, that I think that HARA and TARA are only top-down or bottom-up analysis methods for risk assessment and trait assessments, and doesn't specify a test method or test strategy. So my question is that if you think that is also security related standard, similar to the SOTIF standard for the intended security issues.
It's a fascinating question. Fascinating question. Elgarbabi, where are you from again?
From Germany.
Mm-hmm. And you're working for?
Mercedes-Benz.
Mercedes-Benz. Fascinating. All right. I love your question. Yeah, I mean, first of all, you really set the premise really well. Yeah, you have SOTIF, HARA, TARA. You have 3 standards, ISO 26262, ISO 21434, and SOTIF. So these things need to be harmonized. I was actually noting when you were saying, you talked about, tests. There are different test scenarios. Before coming to your question, let me also talk a little bit about that. Right now, there is kind of like a panic in a sense. It's not really a panic, but people are pessimistic about the fact that they'll have to deal with now different test cases for security, safety, SOTIF. So SOTIF takes it to a different kinds of test methodology. So we are used to the requirement-based test cases. So we have a requirement, and you design a test case for that, and you validate. Now we have scenario-based test cases. Now I see a lot of synergies in these things. So those scenario-based test cases that you will develop will be actually coming back to one of your requirements. I don't see that you can test anything that will not be traced to one of the requirements. So you don't have to do double work. There are a lot of synergies. Also, safety and security will have synergies. In what sense? We talk about memory partition in safety, right? So in security, we have the notion of escalation of privileges. It's literally the same thing. Your lower AZ level should not talk to the higher AZ level. In security, your lower CAL level, cybersecurity assurance level, should not talk to the higher ones. So you don't have to do things twice. Or integrity, for example. If you apply crypto, you don't really need any other integrity testing mechanism. Now coming to your question, do we need anything like the security of the intent and functionality? I really like that question. I would tend to say yes. It took a long time for the safety community to understand that failure is not the only reason for safety fatalities. Failure is not the only reason. Statistically, we have more people dying outside the vehicle than the vehicle itself. We did a pretty good job securing the persons inside the vehicle, but now more pedestrians, bikers are being injured. This is why we had the necessity to have something like safety of the intended functionality. What I would say is we don't really have enough real-life data when it comes to security to say that we need similar things for security. Because although, like I mentioned, you have vehicles out there in the street with no encryption in their CAN network, but these are not attacked on a regular basis the way a corporate IT infrastructure has been attacked. The internet criminal industry is not paying full attention, is not giving their full energy in automotive. This is going to change. When IT infrastructure is going to be more difficult to attack, they're going to perform attack on the vehicles. And then we will see why we need such thing as security of the intended functionality. I think an autonomous vehicle is going to be needed anyway, no matter what. Because when it comes to autonomous, a lot depends on the environment. So your environment tells you what to do. The environment tells you what not to do. So here, I agree with you. Something like this would be needed.
Yeah, the point is that the absolute safety is not reachable. And this is the reason why we need safety of the intended functionality. From my opinion, that is also the absolute security is also not reachable. For this reason, it's also necessary to think about relativity, how to think about relativity and ensure that the system is also secure.
I totally agree. The most secure place to be is a cage made of metal where you have absolutely no connectivity and nothing at all. But that's impractical. And I totally agree with you that we cannot reach absolute security or absolute safety anywhere. We need to relativize, and for relativize, we need data. I think we need to just wait and see how the very first security standard, works for us. And the interesting fact is ISO 21434 does not talk one word about autonomous vehicle. It's not even within the scope of ISO 21434. So we have a long way to go when it comes to autonomous vehicle. We'll definitely need maybe a specific standard for autonomous vehicle security, and that would probably go toward what you're mentioning is security of the intended functionality.
Okay, many thanks for your detailed answer.
Next question, Michelle. Chitra.
Person, this is Chitra here again.
Welcome back, Chitra.
I would like to get your opinion on one of the misconceptions among many of the engineers that functional safety is just a documentation. I think the actual real essence of the best practices of functional safety is not made use of So as you're having a huge amount of consulting experience, can you suggest few of the motivating steps so that we can improve the safety culture or the mindset of the people in any of the organization?
It's a fascinating question. Fascinating question. When I talk to my clients, we're a tier 2 company. When the safety goal comes to us, it's kind of way too late. We cannot influence the safety goal. Now, there are two ways to do it. One, you just mentioned documentation. I have to fulfill a checklist. ISO 26262 is merely a checklist, right? You just have to fill up this, okay, if we did this or did that or not. That's one way to do it. The way we work in Matrickz is always the end consumer. How can I protect the end consumer from injury? And once you have that in mind, all of a sudden, safety engineering becomes really interesting because you understand the big picture. It's kind of like the aha moment. Once you understand safety engineering, then your traceability is not merely paper traceability. You understand the traceability in your head where the vehicle level safety goal is coming from. And then your engineering becomes not only interesting, there is a big ROI to that. People often underestimate it because I have seen, in case of safety, people over-engineer safety a lot. The reason they over-engineer, they see, okay, there is a ASIL coming to my software component from somewhere, and I have to do everything that is required for that ASIL level. Now, it's often the case that they don't understand or they don't want to think about where the vehicle level safety goal is coming, and they could potentially even save a lot of money by isolating those software components which are not affecting the safety goals. Functional safety manager it's also a negotiation position. You have to be able to communicate with your counterpart, with your clients in a way that you understand the engineering argument for your safety level, not only the historical one. And this is where you can actually also save some money once you understand the way you are saving lives. It becomes so much more interesting to work in functional safety than just to apply things that's coming from the top and just fulfilling the checklist.
In addition, I would like to add few points, maybe the proper risk analysis from the respective engineers at all levels. Either it can be developers or the requirement engineers or the one who does the verification and validation also could add on. They should also think from the risk if anything goes wrong in their task, if it is really hampering or it is disturbing the safety, then they should actually think in that perspective. That's what I think.
I agree. So I've often seen when I go and train my clients in a functional safety training, a room full of developers, I ask them a question, what do you understand by functional safety? The answers are often very siloed answers, like MISRA C or memory partitioning, which is 100% correct from their perspective. But what's missing is, like you said, the holistic understanding. The traceability exists in papers, but the traceability in their head is missing. And that's important.
Yeah, thank you.
Okay, we will take some more questions. If you have more questions, please write the letter Q in the chat box. We will be happy to answer your questions. In the meantime, our colleague Lucas, thank you very much. He solved the problem of downloading the paper, so you're able to download the paper. Please send us your feedback if you like the paper. If there anything that you would like to add to the paper. We will be doing a series of podcasts also on ISO 21444. And yeah, the Matrickz team have been working really hard on this white paper. Although I am the author of the paper, it's like I do want to give full credit to the Matrickz team. They've been giving me a lot of inputs and doing a lot of hard work to make this paper success. Yeah, we have last question. Let's take the test question and then we'll go from there. Yeah, Ram Kumar.
Hey, thank you so much, Hasan. The one request that I have is, can we continue doing this session probably, I would say, over a webinar, right? Because I see that a lot of people are benefiting out of the session for sure. And the global exposure, we don't really get it in a lot of sessions. So I think the one request that I have is, can we continue doing this at least yearly once, where we have a webinar session like this meetup where we have the subject matter experts coming in and talking about the topics. I think it's going to really benefit a lot of folks out here. That is one request that I have here.
Ram Kumar, I really appreciate it. Yes. In the previous sessions, what we had is we had personal meetups, so people would be here. And we also had a live televising over YouTube, and you were able to ask question over YouTube. Today's experience showed me the Zoom experience is much better, is much more interactive, and we definitely will continue this. Even if we do a hybrid model, this part that we're taking people online will be there. So we will definitely take online participants in all our meetups, even if we do a hybrid model when the COVID-19 gets a little bit better, when people will be able to come. We'll still continue this. Thanks so much for your feedback, Ram Kumar. Really appreciate it.
Thank you so much, Hasan. And I have one final question before we wrap up. Right?
Yes,
so
please.
We talked about the similarities between the cybersecurity standard and also ISO 26262. Now, do you think, in your perspective, that it is good to have one standard which covers both safety and security aspects of it, considering the structure of the organization and the understanding of the safety and the security requirements? Do you feel that one standard would make sense rather than having two different standards? I know that the objective is different. I know that the purpose of the standard is different, but do you think it makes sense? Because the V model, it's going to be the same, right? The V model that's been referenced in the cybersecurity and also the functional safety would be the same. But the activities and tasks that you may do will be different. I agree. But do you think, in your perspective, one standard would make sense?
Very good question. If one standard would make more sense than having two different standards. Let's look at safety and security from independently first. When it comes to security, there are 4 different impacts, and at least 2 of them have practically most of the time nothing to do with safety, which is financial and privacy. You have to also deal with these 2 issues when it comes to security. Now, when it comes to safety and operational, there is no way your ISO 26262 can work in segregation from the security standard. Now, if you would put in one standard and make the scope bigger, or we'll have 2 different standards, well, they're harmonizing interfaces, practically there will be no difference. It's just a question of, how do you want to organize it? Even if you have one standard where you're talking about these 2 different things, you have to broaden the scope, because you have to take the financial and privacy aspects of security in consideration. You have to take a lot of things in safety in consideration that probably is not one-to-one related to security. In my opinion, it wouldn't make any difference. It's just a question of structuring the standards.
Yeah, I agree. The reason I wanted to ask this question is more on the interface that we talked about, right?
That is a very important part. You have to have the interface defined in a way. It has to be, in the V model, you have to go in loops. Because when you do your Tara, when you do your Hara, you are talking about the same vehicle. And you have to then sit down and see, hey, if my Tara has some impact on your Hara and vice versa. And we cannot also forget the SOTIF, because people will be doing, for example, casualty and risk analysis in isolation. You can't, again, do that in isolation. You have to come back and discuss and go back and rework on the impacts that you will have on one another.
Sure, I agree. Yep. Thanks for that, Hasan.
Thank you, Ram Kumar. It was a lovely session. Okay, we'll take this question. This will be the last question we have from Narashima. Narashima, you should have the mic now.
Yeah, so can you hear me?
Yes. So Narashima, why don't you tell, I know you, but you can tell a little bit about yourself for rest of our audience.
So hi Hasan, I am Narasimha. I am into automotive industry itself. I have been associated with automotive for 3.5 years as work. And then I'm doing my master's, and also I'm working with Matrickz as an intern. I have a question here that as we are talking about autonomous vehicle, so how can one establish a coordination between an autonomous and a non-autonomous vehicle on a road? Means there can be a situation how that a autonomous algorithm-driven vehicle have to compete with a driver or human driver. So how we will coordinate between this scenario?
Very good question, Narashima. So we have already seen during the testing phases. So I will extend this question into 2 parts. One is a fully autonomous vehicle and fully human-driven vehicle in the same environment. How does that work? There could be another way of seeing this, a semi-autonomous vehicle. That means there is a driver behind the wheel and the vehicle is autonomous. So let's talk about these two scenarios. I think the scenario that you're talking about is more the scenario where there's a mix in the environment of autonomous vehicle and human-driven vehicle. Now, we have already seen in such cases, because right now we have most of the vehicles are human-driven. When autonomous vehicle goes for testing in the roads, we've seen that autonomous vehicle is trying to comply 100% with the traffic law, 100% right, but it is the human who has the intention, and they're kind of like cutting the edges, and it doesn't work. And my opinion is it is not going to work in the future. The dream of having a level 5 car that's going to do everything is a little bit far-fetched in my opinion, but we're very close to a level 4 or level 5 in a geofenced environment. And when you talk about geofenced environment, we talk about maybe an autonomous lane like we're building in Bayern only for autonomous vehicle. And the mix is going to be very difficult and in some cases fatal. Because human behavior and the way software is programmed is very, very different. You are programming the autonomous vehicle software also in a probabilistic model, but that's a deterministic probabilistic automata. Meaning you have defined some deterministic nodes, but you've assigned some probabilities there. And in case of human, I think our decision is absolutely non-deterministic, and hence it's not going to work. Now come to the next scenario 2 that you have mentioned. In scenario 2, the mix of the driver and autonomous, yeah, that is something we shouldn't do. That's level 3, according to the definition of SAE. And level 3 is fatal. We know it from the aviation industry. A lot of fatalities in aviation industry takes place because the driver did not know if he should take action or the plane was in the autopilot mode. And that's exactly going to happen in automotive too. Even my ADAS function, if I have the lane keeping assistance and the distance assistance, sometimes I'm just assuming the distance is on and I'm not taking measure. And I realize that's already happening today with your limited ADAS functionalities. So I think we shouldn't even go in that route. And there are OEMs out there who will be skipping level 3 and going to level 4 straight away.
Mm-hmm. Yeah.
Thank you, Narushima. So I think we will wrap it up. Again, thank you very, very much for all of you for attending. It's very late in India. I really appreciate people from all over the world joining. We'll keep doing this more often, and definitely the online version that we have seen today worked really well. We're going to keep it. Even if we do a hybrid version, the online version will always be there. Thank you so much, and stay safe, stay healthy. See you next time. Bye-bye.